Hello, my name is Willow, and today I'm going to be talking about mutations that can sometimes happen in protein sequences depending on whether an addition or deletion of a single base pair occurs. I'm going to work through an example, and we're going to figure out what kind of mutation occurred that resulted in the frameshift mutation shown on the board. We are given a normal protein and its corresponding sequence of amino acids up top and a truncated non-functional mutant protein on the bottom. It is our job to figure out how a mutation in the normal protein resulted in this mutated protein and then determine the coding sequence of the mRNA that will be translated into this mutant protein. The first step is to look at the coding dictionary and write down every possible codon that would work for each amino acid given below. Then what I do is I look to find the first point of difference between our two proteins. So going down the line, we have MET, TRP, and this third amino acid is the first point of difference. I then have to decide if either an addition or a deletion will give me one of these codons below, either AUU, AUC, or AUA. So I know, given these two codons, that I will need to add an A here to satisfy this. If I do that, I have AUU or AUU. So I know my codon down here for my mutant protein is AUU. Then I keep going down the line. I look to see what the starting letter of my next codon is in my mutant one, which is a C. Due to that, I know that if I section this off as AUU, my next letter will be a C. I just imagine that all these codons are sort of pushed together in a line and I can just go down. So I have C. And so if I'm connecting it, it can either be CAC, CIC, CIC, or CAC. So I know that my codon for HIS for my mutant protein will be CAC because that satisfies this. I then have to look at the next letter of my mutant protein, which is a U for my stop codon. So if I go here, I go ACU, ACC, ACA, or ACG. If I section this off, CAC, since we just found it, we know that it's going to need to be ACU in our starting protein because this will give us the U for our stop codon. And so we need to look at one more amino acid in our normal protein to figure out which specific amino acid we use down here. So it can either be UAA or UAA. Therefore, we know that our stop codon for our mutant protein will be UAA. You can section it off like this. It doesn't really matter for which one because in this case they both satisfy. So we know that the mRNA sequence of our mutant protein in this case would be 5' AUG, UGG, AUU, CAC, UAA, 3'. And that is how you can figure out a mutant mRNA sequence given a normal protein sequence.